Okay, so let's continue. So the question for today is 6.17 out of C6H5CH2Cl and C6H5CHCl. That means this Cl is in bracket substituent C6H5, which is more easily hydrolyzed by aqueous KOH. Aqueous KOH, you know, its substitution reaction will take place, right? Now we have to compare these two chemicals. For that, what you have to do is you have to first make the structure. So let's make C6H5, that means a benzene ring is present, and then it has a CH2 group and it has a Cl in it. Okay, this is your first chemical. Now let's see the second compound, C6H5. Again there is a benzene ring and it has CH group in it, and to that same CH group there is a Cl present over here, and to it again there is a benzene ring. So I hope the structure is clear to everyone. Now which one will easily get hydrolyzed? Easily get hydrolyzed means who will replace this chlorine with OH very quickly? That's the question. So what you do first, you find out the carbon which is attached to this halogen is which degree in both the case. If you see this carbon which is attached to this halogen is attached to one more carbon. Okay, so this is a primary degree carbon, and if you see this carbon which is attached to this chlorine is attached to one carbon here and one carbon here, so this is a 2 degree. So first point is clear. The first point you're supposed to write or find out is which degree carbocation is this. Sorry, which degree carbon it is. Next, in case of SN1 and SN2, both we will compare. Okay, who will undergo hydrolysis quickly. Now, in case of SN1, we know that reactivity depends on carbocation stability, right? So let us discuss SN1. If this chlorine goes, the positive charge will gonna come over here. This is 1 degree carbocation, and who will stabilize this carbon. And if you see here, if carbon get this positive charge, there are two people who is helping here. So obviously 2 degree carbocation is more stabilized as compared to 1 degree, right? So in case of SN1 reaction, C6H5CHCl, this is gonna win. Okay, so compound 2 will have more reactivity as compared to compound 1. Now let us discuss if the case is SN2. If SN2 reaction is taking place, that means if strong nucleophile is there and other conditions are maintained, SN2 reaction, the stability depends on steric hindrance. Less the steric hindrance, more will be the reactivity. If you see here, 1 degree here, there is a 1 benzene ring, and here there are 2 benzene ring. Obviously, if a nucleophile wants to come, it is difficult to come here because there are 2 benzene ring. If you see here, it is very easy. So here, out of 1 and 2, 1 will win and 2 will not win. So both the case is different. SN1, this is going to react faster, and SN2, this is going to react faster. Reasons are different. So the ideal answer, what you're going to write is this. C6H5CH2Cl is a primary aryl halide, while C6H5CHCl is a secondary aryl halide. In SN1 reaction, the reactivity depends on stability of carbocation. Since C6H5CHCl carbocation is more stable, or you can write 2 degree, therefore this will get hydrolyzed more easily than under which condition? SN1. Second, under SN2 condition, it is depending on steric hindrance, and steric hindrance C6H5 has less steric hindrance, so it will get hydrolyzed faster as compared to this. And you can write the reaction. If you can see, this is the 2 degree carbocation over here, and this is 1 degree carbocation. So I hope that